do something just abstract, and it's something that it's very speculative. You don't have to do it rigorously mathematically to see if it really can be done and can be defined carefully. I'm going to say there's some kind of a warping of the time. So you have some region of space-time, and I'm actually going to warp the time. And now what I've done is actually taken more seriously the concept of space-time. Before I was just making an axis, a t-axis and an r-axis is just a graph, right? But now I'm actually assuming that there is some kind of physical entity, so to speak, called space-time, and it has properties, and it has a geometry, and so on. And I can actually somehow warp it. Now, you might think of maybe curving the t-axis, so to speak, but then it curves into the spatial part, so that's no good. You might want to go, if you have just a two-dimensional system, which is one-dimensional motion, you might want to curve it out in the plane, but then you're creating some additional space, embedding space, and it's just, we don't want to do that. So in order to do something more intrinsic, what we do, for example, is a stretching. You can stretch the scale between time and space, and you can stretch it differently at different parts of that one-dimensional space. And then you'll have a time passage which depends on where you are in the space. All right? Now, just assuming one can do that, and it turns out that one can, right? What would happen? For example, if you had a straight world line, which corresponds to an inertial particle, for example, let's say a stationary object, like we're stationary right now, right? So we'll draw our world line straight. What would happen is, of course, this will curve in some way. And if you have a bunch of curved world lines, some of them which have exactly the amount of curvature which is corresponding to the amount of the warping of the time will become straight. Now, in order to be a little bit more precise, again, I won't say they're straight, I'll call them geodesic, because after all, we're used to the concept of straight in terms of space. We're talking, first of all, about space-time, so the very idea of a straight line in space-time, we need something a little bit more abstract, like a geodesic. And now I'm talking about a warped space-time, so that's even more abstract. If one were able to do this so that a stationary particle suddenly seems accelerated or is really accelerated, and certain accelerated particles will, those who had the corresponding amount like of the warping of the time, will suddenly seem inertial. So you have this strange situation that things that would have been considered inertial are accelerated, things that would have been considered accelerated are inertial. And there's a very odd property of this if there were a region of space-time which had this time warping. What would one notice? They realize that if it's a warping of the space-time, then the amount of the acceleration of these supposedly inertial particles is independent of any characteristic. It's not dependent on velocity, not dependent on mass. That's a very, very weird thing. I mean, whoever saw physical phenomena like that, eventually they say, of course, gravity. So if this were possible, and I'll show you in a minute, then one could see that this would be a good way to model gravity.